So I'm going to show you the most complicated thing that I actually did with this game, and it really does help here to have a good understanding of mathematics. I've got to say my maths have never been fantastic, so what I had to do to really get my head around this is I actually went to a spreadsheet and started coming up with this idea that I know in our example I've got flap count to be 60 at the moment. And maybe just for the time being, let's set it to 100 so it's the same as my example. So what I actually did was, and to be brutally honest, it took me a lot of playing around to get this right. But I've got examples of different flap counts, and as we know from the example you can see across there now, it will basically run through flap count 100 times. And in that case, in our game, while flap count is still under 100, so it hasn't got to the end of our flap count, it keeps is flap as true, which of course then means it's running this section here, which is making the bird increase its direction. Now, rather than always changing the bird by -1, it'd be really nice if we change the bird by a variable amount, and that's what I'm trying to calculate here. So over here I'm saying, well, if flap count is 10, what I end up doing is saying 1 minus 10, so 1 minus flap count divided by half of the amount of flaps we're having will actually give me a number to be able to move. Now what this does is it says at the very start of flap count, when flap is 0, it means that we're actually moving 1 in the other direction. By the 30th flap, we're moving 0.4, so it means we're slowing down. And by the time we get to 50, the midpoint, we're actually at 0, which means we're stationary in the air. Now, we start going into negatives when we go past halfway point. And of course, with negatives on the y-coordinate, that means that our bird is actually gradually moving back down. Again, this took me a long time to come up with this concept. You can either stick with your game as it is, you can try out this idea. I imagine people out there have got a far simpler solution to this, but this was the best that I could come up with the small bit of what I have of the brain. So I'm going to go into here and we're going to start trying to see if we can implement this, looking at the example on the left hand side as we go. So in here, if flap is true, what we'd actually do is, rather than change what bird y is directly to -1, we're going to say bird y change equals, let's just flick back and have a look, it equals whatever flap count is divided by half of what the total amount of flaps is. So the total amount of flaps we've got at the moment is 100. Let's set that as a variable just so we can tweak with it later on. So let's call it total flaps. That's going to equal 100. I can now change this 100 to total flaps. Now I can say, put that into our formula, so 1 minus, and let's get this right now, so it was 1 minus is flap time. I think I call it flap count on the other side. So 1 minus flap time divided by, open brackets, half of the total flaps. So total flaps divided by 2, close both brackets, and I think there's a chance that that will work. Now, if the flap isn't working, then we'll just set bird y change to be its standard 1. Let's see if this works. I'll be very impressed if it does first time. So if I hit the spacebar, interesting, we definitely got a progressive motion, but it's not working quite as we expected. So let's just run that one more time and see where we're going wrong. So what it's actually doing is it's lowering and then progressively highering and then setting it back to 1, which means this is actually doing the opposite of what we want it to do. It's progressively making it go down to the peak and then progressively making it go up, and then because we end is flap and make it falls, we just switch bird change to 1 again, which means it's falling. So I've obviously made an error in my maths here, and I need to do the opposite of what this is doing here. And we learnt earlier on how to do the opposite of something. I'm simply going to say, put this all in brackets, and times that whole lot by -1. So now it should do the opposite of what we just saw there. So, very complicated bit of maths going on there. Let's just test that out now. And if I hit the spacebar, oh yeah, we've got something that looks a lot like a jump. The only issue we've got at the moment is mid-jump we don't get the opportunity to jump again, and we'll look at that next.